Okay, so today we are going to implement the next part that is shared memory. So shared memory basically is a block of random access memory that multiple processes can actually connect to that and write or read from this block. Why we are using that? Because the overhead for having access to this part of the memory and reading and writing it is much lower than the other type of inter-process communication. So when you want to do some high throughput communication between your processes, it would be a recommended way. Of course, there are lots of challenges using these kind of methods, but it's worth it if you investigate the trade-offs between using the shared memory and other methods. So if you guys see that there's opportunity that you can make your program better, or you figure out, okay, if I do this, it can help my program become more optimized, just go ahead and do it, in my opinion. So let's go ahead. First, as we explained in the other episodes, so we create a folder, and then we define our header and our basically source code. Perfect. Now let's define the header file. So basically, as we mentioned in the previous episode of this IPC benchmarking series, whatever you call it, we need to define yeah, this macro, just to make sure that we don't face any error while we are including this header in other sources, especially if you worry that there's opportunity that you there's opportunity that you may face some repetitive including the header file repetitively or something like that. The next part is including what kind of headers we want to have access to. So for implementing this part, we are going to use Boost library. You can use other things, but I suggest you use this. And then let's include also this one. Yeah. Perfect. And finally, our utility header, not ours, but, and then as usual we gonna include the core, because we want to actually use the abstract IPC class that we used before to implement our handler. And finally, same as the other methods, we just try to define an alias for the Boost interprocess, just to make coding easier. It's not something like that you have to do it, but it really increases your speed while you are developing. And perfect. So first, let's define the fields. Container size, as I mentioned, the size of the data that you want to receive or read, just to define how much memory block you would need. And then this is the object handler for your shared memory. And also map region, since we want to create that and use the references in our code, we define it as pointer. Okay, so now let's define the constructor as usual. And then also let's do the mode, so we would know that okay, this is the reader or writer, server, client, whatever you may call it. And let's use it right now to perfect. Okay, I think we didn't have. So let's do it like that. Yeah, only this one. And then, yeah, it seems strange that I don't remember that, okay, whether I had that or not, but it's not strange because I'm recording this in different days, and during the week I'm working different projects. Usually I need to review previous codes, of course, those that are programmers or they do system design, they understand what I'm talking about. So for now we just do empty body because we already initialized everything, and then perfect. Yeah. And then let's go and let's go and implement the protected methods that we had. Yeah, perfect. We just need to add override as an annotator for the compiler. He knows that these are the methods that we override from the base class. And then let's go to the other part, the other file. Yeah. Okay, so let's implement. So we define the signatures. Now we implement those, as you know. We already implemented that. Now for the constructor, for the destructor, we just need to release the resources. So let's do it, because now we didn't do anything about the creation of the shared memory. So let's do that first, just for you guys to understand what's going on, and then we do the other one. Oh, I think I copied it. Yeah. That's what I'm talking about. So you don't remember what code was. Well, it's I have a little bit busy schedule, so sometimes I cannot record the programs as frequent as I want. So, but I'm gonna try to maybe upload more videos for those who think that it's actually beneficial for them, of course. Yeah, perfect. Yeah, again, I understand that you guys, lots of you prefer to use the short keys for like going through the pages in VS Code or do a lot of things. I prefer it too, but here, just to make sure that our focus is the code, not to learn the shortcuts or short keys in the VS Code, I'm gonna minimize using those. Yep. Okay. So first, let's create a shared memory segment. And also we're gonna true if something like that already created. Perfect. So we first need to know what mood we are in. Then if you remember, we define here, let's throw it here just for you to see, shared memory objects that we're gonna use for creating the handler for the shared memory. Okay. So first we're gonna define, okay, how you're gonna behave for the creation process. We use open or create, which means if it exists, you just open it, or if it doesn't exist, you create it. And then we need a name. There is a method from our upper class, but this method don't know what is a std string, so you need to convert your string to an understandable C string. And the last part would be the access, which is read and write for now. Of course, for the a simple application that one process write it and one process read it, we can define it differently, but let's do it like that. After that, we need to set the size of this shared memory. So let's call it yeah. Yeah, the underlying thingy was because today I mostly needed to implement some code in Python, and I use different naming standards when I'm implementing different languages, because every language has its own standard and I prefer to do that. It makes your code much easier to read for others, especially for programmers, for system engineers, software engineers, and I mean for all of us. are working in this industry, mostly we work in groups, and it's very important that you write your code in high quality and in a way that you can actually others, your teammates or others, if you are doing an open source, some other contributor can understand it and follow your code. So naming, variable naming is one of those things that are important. Perfect. So I just use the container size that we defined, we initialize in the constructor method because we predefine how much size we need for that object that we are sharing. So that's the container size that we define. The next part would be to define the region. Okay, perfect. Yeah, this method, as you see, we are creating a function and then assign the address of that instantiated object to the pointer that we define. We do the same for region memory. Yeah, perfect. So here we are mapping, we have defined the region that we want to map the objects to. Yeah. I think it's completely understandable, this part of the code, and that would be it. Now for the next part, we say if this client, let's do what? For the client, we again have to define the shared memory section, but there is a different so first we define that we just want to open it, don't create it. That's it. So if there is no shared memory file descriptor, it's gonna raise an error. So it's only open, something like that. Again, same as the previous reference, we need to define the name of this shared memory, and finally we need to determine what is the access mode. So for this one, it's read only. Yeah, and then we are going to define the region as I mentioned. Today at work, I actually I was working on integrating a payload that we actually we recently implemented, integrated to a cloud service that we define in one of our servers in my workplace, and we wanted to stream live data. So the payload that I worked on, actually I use a lot of this inner process communication, because you actually need it, especially if you are active in robotics or data processing or these kind of things, shared memory or other IPC methods, you're gonna use it a lot. So we define this. I think it's finished. Now let's do the terminate, or how we want to end things. Shared memory. What was the name? Yeah. Perfect. We just need to, for this one, we just need to basically delete the created shared memory just to make sure the system release the resources associated to this shared memory. So this is this basically give you make you able to just give the system the name of the shared memory that you define, and the system takes okay. Now that we also implemented the terminate, let's do this. So we check if the status is true, which means we already initialized the shared memory and everything. We just need to make sure that we have all the right we handle all the things memory wise, because one of the most important things in C++ and C programming is memory management and how you handle your resources, especially in embedded system applications. It's very important. Next part would be update, which means writing into the shared memory. Perfect. And let's do it get. Yeah. Perfect. So the signatures are similar, but update implement actually is the logic behind writing, and get implement is the logic behind reading. So let's do the, so now that the region is actually defined, so the way the gate of having access to your shared memory is the region that you define for mapping the data and everything. So let's do that. Here I want to copy the data that the user passed to the function. I want to copy it inside the shared memory. How we do that? We just use a memcopy or memory copy method that I think all of you guys, especially those who use Unix or Linux system, are familiar with. Okay, now I actually got the address, and then I say, okay, which data you need to write. Of course, the data that user gave us, and the size or how many bytes you want to copy, and then after that you just simply return after, make sure that it's completed. And for the get application, we're gonna read the data and copy from the shared memory. Yeah, again we use memcopy, but here we say, okay, I want data to be copied to region memory, same address. So it's like we switch the place of two argument, because at first we wanted to copy from that block section, memory block, but now we want to copy the data inside that, and that would be it. I hope you like this part. Okay, next we're gonna actually wrap up everything and copy these, implement the main function just to make sure we can run the program and do the benchmarking that we want. So I hope you like this part. We will come back and then we implement the memory file, main function.